Now, for the first part, we're going to be dividing integers. What an integer is a whole number, but it could be a positive or a negative sign in front of it. So, my first example, I'm going to have 24 divided by 6. I'm ignoring the signs for the moment. 24 divided by 6. So, let me write a little 6 and a little 24 on the inside. What I'm asking here is what number multiplied by 6 is going to equal to 24? Right? 6 times something is equal to 24. I'm asking what is that something? Well, in my case, I'm going to say 4, right? 6 times 4 is 24. So that's the number I'm looking for, right? How many times does 6 go into 24? Basically, I'm asking 6 times what equals 24? Once again, in this case, is 4. Now, when it comes to the sign, I'm going to give it a negative sign. And the reason why is because my numbers to begin with had different signs. If they had the same sign, I would call it positive. But when they have the different sign, I'm going to call that negative. So negative 4 in this case. Now, looking at this other case, I'm going to say 3. When I multiply 3 by something, and my result will give me 30. Right? 3 times what is equal to 30? Well, in this case, 10. Right? 3 times 10 equals 30. And then in this case, negative 10, because my signs were different. So that is how multiply or how dividing by an integer happens. Right? I'm looking for the integer such that multiplied by the second number is equal to our first number. In my case, number 1, 6 times 4 equals 24. Question number 2, 3 times 10 equals 30. Remember that if the signs are different, the numbers that I give you that signs are different, then my result should be negative. If the signs are the same, then my result should be positive. Now, dividing decimals by decimals, I'm going to be looking at 3 examples. First thing I got to do is the second number should not have a decimal point. If it does, which is our case here, move the decimal point all the way to the right. It's just that whatever you do to one number, make sure you do it to the second number. I'm ignoring the sign for the moment. I'm just going to be looking at this as 90 divided by 36. Remember, I needed to move the decimal point all the way to the end when it comes to my second number. Now, because I moved it one place to the right on the second number, do the same thing on the first number, add a 0 if you need to. All right, so now I'm thinking, how many times does 36 go into 90? Now, this case is not going to be as simple as integers because in this case, I'm going to be dealing with some decimals. My decimal point is at the end of 90, so let me bring it to the top. My result should have a decimal point. So now what I'm going to do is, how many times can 36 go into 90? So I'm thinking 36 times what? I'm trying to get as close as 90 as possible. Let me think of the multiplication of 36. Right? 36 times 1 is 36. I'm not going to start with that. 36 times 2, that's 72. Now 36 times 3, I'm going to call that 108, right? 36 times 3. So when I'm asking here, how many times is 36 going to 90? I'm trying to get a number as close as 90 as possible without going over. So in this case, I'm going to say 36 times 2. Right? 36 times 2, I said, is 72. Let me subtract this. 90 minus 72 gives me 18. The cool thing about decimals is that after the decimal point, I have as many zeros as I need. Now my question is, how many times does 36 go into 180? When I think of my multiplications here, 36 times 4 is 144. 36 times 5 is 180. So how many times is 36 going to 180? I'm going to say 5, right? Because 36 times 5 is 180. When I subtract this, I don't get a remainder. I remainder of 0. So my answer is going to be 2.5. Negative in this case because my numbers were different signs to begin with. So my answer is negative 2.5. All right, let's take a look at another example. The second number should not be a decimal, which is what we have. I don't care about the first number as long as the second number is not a decimal. So I'm going to ask myself, how many times does 5 go into 6.1? Let me bring my decimal point all the way up. So I'm going to start. How many times does 5 go into 6? I'm going to say one time. I'm trying to get as close as possible to 6 without going over it. I know 5 times 1 is 5. When I subtract this, I get 1. All right, let me bring the next number down. Now, how many times does 5, remember I brought this number down, how many times does 5 go into 11? And I'm going to say 2 times because 5 times 2 is 10. Let me subtract this. I get a remainder of 1. After the decimal point, I have as many zeros as I need. So let me bring down another 0. How many times does 5 go into 10? I'm going to say 2 times. All right, 5 times 2 is 10. My remainder is 0, and I subtract that. So my result will be 1.22. Positive, since the numbers at the beginning were both the same sign. All right, let's take a look at one more example. The second number should not be a decimal. So let me write this as 13 divided by 2. I move the decimal point one place to the right on each. I'm ignoring the sign for the moment. I'm going to look at this as 13 divided by 2. At the end of 13, there should be a decimal. So I'm going to bring it up. So how many times does 2 go into 13? Trying to get as close as possible without going over. I can multiply 2 times 6 because 2 times 6 is 12. I got pretty close without going over. Let me subtract this. So I get 13 minus 12 is 1. After the decimal point, I have as many zeros as possible. Now my question is, how many times does 2 go into 10? I'm going to say 5, right? 5 times 2 is 10. When I subtract them, my remainder is 0. So my result will be 6.5. Negative in this case because my numbers were different signs to begin with. That's how we divide decimals.